Welcome to the Penn State Horticultural Research Farm. My name is Francesco Di Gioia. I am Assistant Professor of Vegetable Crop Science in the Department of Plant Science at Penn State. And today I want to show you another experiment that we are doing, another project we are working on here that is about soilless vegetable production system. Soilless production system are systems in which we are growing plants without any soil or anything that looks like similar to a soil, and we are feeding the plant with water and nutrients that they need. They need 17 different nutrients, and the reason we use this type of system, this type of production system, is because sometimes we have issue in the soil and we cannot use the soil in a very efficient way, very productive way. We have soil-borne pathogens and other things. The objective of this project is to demonstrate how this technology works, and we want to compare which one of those systems is more efficient in terms of use of water and nutrient, and in terms of yield and quality. And we have two varieties of basil here. Green basil, this is Italian Genovese basil, and this is opal purple basil. And they are very interesting. We choose these two varieties because one of the things we want to look at is also the nutritional profile. Through this system, we are not only going to look at the yield, but also at the quality, the nutritional aspect. So now I will invite Andy and Trevor, two students that are working with me on this project, and they will explain the details of the system that we are
My name is
using.
Trevor Johnson. I'm an undergraduate student in the Department of Plant Science in the horticulture option. My interests lie in vegetable crop productions in the hydroponics and high tunnels. Today we're going to talk about the deep water culture. In the deep water culture, the roots of the plant are submersed in the nutrient solution, and so they'll pull up any nutrients that they need through the solution whenever they need it. So this system is just run with a nutrient solution in the 50-gallon tank, and we pump in air for circulation as well. Since the plants receive all their nutrients from the water, they also need oxygen. So with that, we actually pump in oxygen into the nutrient solution using the compressor and these rocks that help distribute the oxygen through the system. And that is how they get their oxygen.
My name is Andy Blanc, getting a master's in horticulture, working with Professor Francesco Di Gioia in the Department of Plant Sciences. This is an Nft Hydroponic System, and the way that this system works is we have our nutrient solution in this reservoir down here, and we have a pump that is going to pump the water all the way up here, and it comes through this little tube. And the water you can see here is just going to stream down this and then enter down here and back into our reservoir again. So you can see here that the water is just streaming down here, and you can see that the roots are spreading out across this and they're taking up the nutrients across this. This is a dynamic system, which is in contrast to our other systems where the water is always moving and there's always moving parts. Also, when it comes to oxygen for this system, because there's just a small layer of water that comes through, there's oxygen that's available to the roots.
An alternative to this is what we call a sub-irrigation system or ebb and flow system. This also has a reservoir tank that is used for a closed system, and we have a small pump in here. And the way this works is once, like a couple of times a day, 3 times a day, the pump pushes the water in this tank, and it goes like up to you can tell the height here of the nutrient solution where it gets, and from the bottom the water goes up by capillarity, and then the plants are able to take that nutrient and the water. And in this case, we are using an artificial media, a soilless media. So this is simulates the soil, but it's not actual soil, and it does. This is a mix of peat and perlite, so that it can provide a good airspace, so that we don't need to worry about the oxygen. And at the same time, the peat has a lot of water holding capacity, so we don't need to have constantly the water there. It's enough to have it like 2-3 times per day. And what happens is, if there is an excess of nutrient, those excess of nutrient will accumulate in the top of the plant, while most of the roots are going to be at the bottom of the plant. So you can tell from this little thing, it's still the plants are young, so they do not colonize all the substrate, but most of the roots are at the bottom, while the excess of nutrient will accumulate at the top, and that will help to even manage like salinity stress if there is an accumulation of any element that the plant is not taking up. What we're going to do is compare, the yield and the nutritional value of all these three systems, and we have some also in the soil, so that we can see also how the soil compared to soilless system.